All right. Hey, this is Plutus PBL live coding from Gimbal Labs and Friends. It's the 12th of October, 2023. We're getting together just like we do every Wednesday and Thursday at 14:30 UTC to talk about the stuff we're working on. What are we working on? We're all working through the Plutus PBL course, which you can find here at plutuspbl.io. Anybody's welcome to start anytime. And we've got a whole bunch of different content we cover. And there's actually a brand new module. In yesterday's live coding session, we added module 303 to the available list that people can commit to. I want to give a huge shout out to Augustine, who built this module in its entirety, from the learning targets to the written content, to the example repositories, to the videos. So very, very cool to see this live. There's a couple of really interesting questions that he and I had, and we decided that when the time is right, we would like to bring those to these live coding sessions. It has to do with the proper serialization of datum and redeemers when you're building transactions to interact with a contract compiled from Aiken. But we really want to share that journey with people when they're ready. So as you know, everybody's moving through this course at their own pace. And when a critical mass of us are here on Aiken, we've got some fun sessions that are going to pop up. But I don't think it's for today yet. So just know that that's there. You can jump in anytime. But for today, same question as usual. How's everybody doing? What are you working on? And what could you use some support with? We'll take some notes and then decide how to use our time. Hey, everybody. Anybody blocked on anything that you're working through right now? Mr. Paban, one of my favorite lines of the week was Paban being Paban, when Newman said that earlier.
Thank you so much.
Oh man, oh man.
Erez, hey, what's going on?
Yeah, hey everyone. I got stuck on what is it, where I need to prove that I sent. Hold on, I need to find which actual module, and I'll let you guys know.
And then in the chat, yeah, definitely assignment 301. That one's going to be a blast to explore. That can definitely be something that we look at today. For anybody who's not there yet, 301 was our first deep dive into Plutus validation. And the assignment here is, you're starting to see in 300 and beyond, the assignments are going to be a little bit less helpful. One of my favorite math mentors when I was still in the high school classroom, that was his slogan. He was like, the teacher's job is to be less helpful. And so as we start getting into these, you'll see, right, there's less here than maybe there was in the 200 level projects. Okay. But there's some exciting stuff. And starting from here, we can absolutely talk about this anytime. And I think it's fine to use some live coding time for this, even when people aren't here yet, because this is going to expose you to some concepts that you've already seen earlier in the course. So that's on the list as a possible thing for us to do today. Ooh, crafting TX at back end. Ooh, whose is this? Where's that coming from?
It is me.
Yes, sir.
Mix.
Teachers having some ideas. Oh man, that's very exciting though. What else?
Yeah. I'm still stymied. I'm stymied back before. I was expecting to go through the assignment 301, like the new thing, but maybe we all did that yesterday. I was traveling, so
Yesterday we did a different kind of session. There were only a few of us here at the start, and Claudio mentioned that he was unable to commit to module 302, and there was actually a good reason for that. And I took the chance to just demo how this PPBL application works. Like, what are you allowed to commit to, and where is that coming from? So it was a little bit of a deep dive into the plumbing here. Yeah, I think that, but you didn't miss anything that's like part of the course.
Oh, actually, I think I did. I was sort of listening to it as I was traveling, so I wasn't at the keyboard, so I couldn't sort of follow along like I normally do. But it was cool. There's a few tidbits. I always get a few tidbits when I listen in. But yeah. Just in general, I don't know if this goes onto the thing, because Harsha and I are doing the CS50 and just sort of trying to polish up our foundational computer science, and one of the things that I'm coming across is visualization and trying to figure out how to debug things. And I guess the thing that I'm working on now is like the whiteboard pseudocode, like not necessarily the 40,000 foot, but not the 1,000 foot either, or the 10 foot or the 1 foot, there's a somewhere in the middle where you can to visualize things such that you can break them apart to all that getting down to debugging. When something goes wrong and you just have this big block of code, I think that I've seen it done where they're like, okay, and what you do, and we did this yesterday where you're like, okay, where is this? And you just follow this giant trail. But unfortunately, at 50 years old, my I don't know if it's my memory or like the ability to hold things in working memory. It's great to have a visualization. So all that being said, I would love to get some strategy on, especially with new concepts, like all this terminology and all these sort of things. Is there a visualization, or do you all listening have like a technique of how to whiteboard it or put it out there? Anyway, that's maybe a wall of words, but that's what I'm in a very authentic way.
It's so timely, and there's we all have our limitations about learning things, but two things really important, right? No matter what, It's hard. Like just the ability to build a mental model about writing a program, especially anyone that has a meaningful scale, right? We're talking beyond hello world and that kind of thing, right? That's already a hard thing. It's doubly hard because no matter what resources we could point all of ourselves to about visualization, debugging, pseudocode in general, and I'm glad you're getting those concepts from CS50, but we're figuring out how to insert into all of this the blockchain, UTXOs, transactions, right? So there's like a multi-layered challenge in front of all of us. So don't worry. I like, and all, like Nelson and I were just sitting there with Adrian, we were all banging our heads against precisely how to organize a project. And if it was just a simple Web 2 like to-do list application, we could go on YouTube and somebody would show us, here are the best practices for how to structure this application. But when you're building a dApp on Cardano, those best practices barely exist yet. There's a couple of SIPs that have some suggestions for how to move that direction. But when you're building a complicated application with 4 different smart contracts that each have a bunch of different transactions, but that rely on some of the same data, how do you organize all that stuff? It's really hard, and there's nobody to tell us how to do it. So I hope that helps just a little bit in terms of feeling.
Yeah, it does, because I was just like, am I just out there in the woods, by myself? But it sounds like no, this is something. And especially once things get to that super, I mean, we are adding layers of complexity, and which is fine. And we do have these superpower tools, ChatGPT and the LLMs, being one of them. But it feels like the last generations of computer programmers have put these things in there. For instance, I went down a rabbit hole of UML, modeling, a universal modeling language where you can, loops and, functions and inputs, outputs, APIs, all that type of stuff. It feels like there is a, mid-level language. I guess then it gets into all these sort of abstractions and, but yeah, that's I'm glad to know that is sort of well received and it's in the hopper, because I feel like that would be something really beneficial. And if we can lay those practices, down, then that would be really cool. Yeah.
We're getting to the time where we can start thinking ahead to, hey, like, what's Plutus PBL 2024 going to be?
Yeah.
And I think a really fun goal that we could all share is let's improve the visuals, right? Maybe we're happy enough with the flow of the course, but at every stage there could be better visuals, or there could be better, right? We could have some implementation of UML or an adaptation of it to think through these things. Mix, do you have some of those early diagrams you drew of contract systems in Draw.io that you could show people?
I think it's still available in Smart Contract Gladiator in GitLab, and it is open source, so people can check it out.
So, I mean, and those are unruly. It's really right, like there was so much real-time learning going on, just figuring out how to draw those pictures and talk through them with each other, and that's still a work in progress. All right, actually, I have an idea. Era's in the chat found that he's working on a lucky number assignment, right? Which is actually just a intro version. There's a lot of similarity between the lucky number assignment and assignment 301. It's just that this one's a little more challenging and we help you less. But what if today we tried to combine all these things? We could start, Eras, you could show us where you're at with the lucky number assignment. And then as we're working on that, we could think about drawing a picture of that transaction that we're trying to build. And then if we're happy with that, we can apply that kind of diagramming now to assignment 301 and see how far we get. While along the way, let's keep this question in the back of our mind. When you start to build transactions, you can start to imagine steps that eventually you would want to automate. And when we talk about automating anything, including building a transaction, that's where things like Mix is saying start to get really interesting. How could I build a microservice hosted on a server somewhere that helps me build transactions like this one? And there's an important connection. I can't build that microservice until I have a good whiteboard implementation of the idea in the first place. So what if we keep this question in our minds for now and maybe use that as a lens if we have time at the end to kind of see how this went? If that was our agenda today, how would you feel?
It's got my full attention for sure. Let's do it. That is I mean, and this actually is a great sort of example of why we put all of our things in an authentic way, because it's just like, oh yeah, these all do fit together in some way. So yeah, that'd be wonderful. And even if we just got through number one and helping Erez with lucky number, that would be great. I did it, you know, a month ago or so. And so that would be great refresher.
Yeah. Yeah. Oh, and there's more insights for all of us each time. I learn about it each time we look at it. And we
Right.
know that today our lens is, let's look for things that are going to help us with this. Erez, are you prepared to be put on the spot? Can you drive?
Yeah, just give me like a minute. I'm here alone with the kids, so I'll do my best.
Oh boy.
Yeah. Yeah. I feel like challenging myself.
Nice.
It's just adding an extra layer on top of everything else. That's great.
Yeah, but I put on a movie and they ate a little, so it should be good.
They're right in the zone. Perfect.
Yeah.
Okay, well, let me know when you're ready. While you're getting set up, just a tiny bit more context. I've mentioned this before, but we are in the early stages of planning a dedicated mesh PBL. Okay, so when it comes to specializing and contributing, our original goal with this course is starting to be brought to life. Right? We're not going to be stuck in this course, but we're going to be able to branch out to other places. And just for additional context, this idea that Mix brought, right? Crafting transaction with the back end, sending it to be signed and submitted. We're also in early conversations about building like a Cardano Go PBL course. The team over at Blink Labs has been building some incredible services in the Go language. And that's something we could look at any time, but there's some early work going on there. And it's delightful. So yeah, that's on the horizon.
Cool. Big things afoot. That's awesome.
No worries. Okay, can't right now. So let's just instead of then live troubleshooting the lucky number, let's take a super quick look at what that assignment was.
Yeah, nice.
Right, and then we'll take that and we'll go over to items 2 and 3 on the agenda. I think it was here, right? Yeah, change your lucky number. So you start to learn how to build transactions and you learn a bit about Cardano CLI. And so for people who have a node running, hopefully you've had some of the pleasure of seeing how Cardano CLI works, and you've had a few successes building simple transactions, right? Just sending a little bit of funds, right? This is maybe the simplest transaction I think we could build. It has only one input and only one output. Technically, it has 2 outputs because change address creates one with all the leftover lovelace, right? But that's the concept. And I know that everybody here is at a different point in their journey. Maybe this looks super familiar to you, and maybe you're still wrapping your mind around this, but in any case, this is kind of the concept we're playing with. And you learn a couple of other types of transactions. And finally, we get to this one where the goal is to, well, without talking about Plutus, the goal is to change your lucky number, right? If I look at a list of contributors, everybody has a lucky number associated with the contributor token that they minted in the first module. And by default, the lucky number on that token is 5, right? But you can see for a lot of people, it's no longer a 5. Those are all the people who were able to get through the assignment that we're just looking at right here, changing this lucky number. Whoops, I meant to go back here. And so the guidance for how to do that is provided. And maybe this is starting to look familiar as datum, and maybe this part, the Plutus part, is starting to look familiar, okay? And then you're kind of guided through that process, okay? But to keep going on this, let's take a really quick look at just the validation code that's in question. And then let's see if we can look on GraphQL to find a bit of this datum on chain. This would kind of be a bridge to what we looked at yesterday. So we are trying to remember where we provided this. Oh, we just had you build this one by hand. Okay, but it's the contrib token validator. So give me just a second here. Let's jump over here. So this is the repo that's linked from the course, and this is our contributor token. The validator right here has 2 endpoints. Okay, and what I mean by endpoints are the names of the redeemers that define how we're able to interact with this validator. One of the validators, one of the redeemers is for updating the number of, the list of completed modules. And notice that this one can only be done by an admin, right? So when somebody comes over here, and we've got a list of current commitments right here, we saw this yesterday, right? For this distribute transaction to work, the connected wallet has to have an admin token in it. Because only, right, an owner or a teacher of the course can add more completed modules to your list. In other words, this list right here. But the lucky number is a different part, right? So for Claudio, for example, it's a 7. That lucky number can be changed with this other redeemer. And the rule here is different. You don't have to have an admin token. You have to have both contributor tokens present in the transaction, right? And so this is just showing you, hopefully, like a relatively simple example where there's 2 different roles, and each of those roles can do a different thing. Admin can do this, contributor can do this. Any questions there, whether this is new to you or you've seen it before?
Yeah, I've seen it before. It's done, and it's like on the second or third. I think this might be like number 3 through for me, but it's like, oh, this is pretty simple relative to what we were going through yesterday.
To me, I think this is revolutionary. The fact that I can put some data on the blockchain and then I can target in very specific ways who can change what part of that data. And I can have many different roles and many different data points and make it all work together. Now, really quickly, we also saw in the PBL front-end template, this is where our course is living right now. We saw this GPTE config thing, right, which has a bunch of, this has the addresses and the Plutus scripts and the reference UTXOs in question. Just remember, this address right here can be queried anytime. And so we can look at GraphQL, for example, and we can query a contract address like this. Right? And I can say contract address, and I can set it equal to this. And this is going to be a lot of data. I'm not going to be able to see all the UTXOs because how many are there here? There's 188 UTXOs stored at this address, each of which maps 1-to-1 to the contributor tokens that everybody holds in their wallet. But if for any arbitrary one of these, I look for the datum, I can see examples of, oh, here's an example where the lucky number is still 5 and there's nothing done yet. That's okay. But maybe there's another example here. Here's somebody changed their lucky number to 6 and has finished a whole bunch of modules. Any questions about that bit?
So that address has 1/2 of the contributor token pair. Is that right?
Correct.
Right. It's just got one of the tokens of the pair. And that's how, okay.
Right.
And this address is where this datum is stored.
Yes.
The datum is not stored with the, wait a minute.
Mm-hmm.
It's not stored with the, so contract is, it does get down to terminology for me at this stage. It's not stored. Yeah, just sort of vaporized. But it is interesting how it comes into focus, like if you work with it, and it's sort of right back there, but then for me, it's come in and out. But
remember that datum is stored in a UTXO, right?
Right. Yeah, I guess that's what it is. It's not a UTXO. It's not. It's like those are the.
Everything. This is a query of an address for all of its UTXOs.
Right, exactly. So all the UTXOs are sort of at an address, and inside of those UTXOs is the datum, and you can see that in the CLI wallet.
I could query this address with Cardano CLI, and it would fill up my screen.
Right.
188 UTXOs and that mess of datum, but you could read it. And if you make an out file there, that's another way to see this same data right here.
I noticed that in the transaction. Yeah, that out file. Yeah. Which is formatted maybe in some way.
Understanding that this datum is in a UTXO.
Okay.
Also understanding that every time we send a token somewhere, a UTXO is consumed and a new one is created.
Right.
You can start to see the problem that's being solved here. We want some data associated with your contributor token, but we don't want you to have to recreate that data every time your contributor token moves. And B, we don't want you just to be able to change that data to wherever you want.
Right.
So we lock it. We lock it in a UTXO that is 1-to-1 associated with your contributor token. And this is the innovation suggested by CIP68.
Right. With this paired token thing. That's CIP68.
If I looked at this token name right here, and I decoded it in hex, what I would see is this first bit right here. You see how it says, oh, wait.
3230. Yeah.
No, where is it? Here it is. Sorry, that's a like pattern, but it's not what I'm looking for. This is 313030. That's 100 in hex.
Right.
And then 5050424C, that's PPBL.
Yeah.
And here's 2023. 2023. And then here's the alias that somebody chose for this token.
Uh-huh.
So somebody out there has a token with the same policy ID and an almost matching asset ID. It's just that instead of the 100 right here, it's a 222. Or on in hex, it would look like 323232.
Right.
And that's an arbitrary way to create that relationship, but it does work. There may be alternatives. How can I associate by name the token in somebody's wallet with this is starting to be common parlance, the reference UTXO or the reference token that's stored somewhere. So we have this way of attaching this, and now this token isn't just getting sent by somebody's wallet all the time, right? The token out there in your wallet is free to move around. And when it does, you can send your contributor token to your other wallet, to your CLI wallet, to somebody else, and it has no impact on this data, none. Right? So where is this stored? What is this address? This address right here is the address that's built from the compiled validator script that we're looking at right here. Oh no, sorry, I'm back in the front end template. I meant to be looking at
Right. Yeah. Exactly.
where we just were in that validation code.
Yeah.
Here, right? So this contributor reference validator compiles to this address, which means any UTXO locked at this address can only be unlocked according to these two rules right here.
Yeah.
So let's go back to agenda item number 2.
Yeah. I mean, that's funny because I mean, I don't have a map at hand, and it's interesting how visual like mental models work. Like if you work on something all day, you spend all day with it, and for me, this is just for a 50-year-old brain, like the mental model is clear. It's just like, oh right, I've gone through I've been working in this house, and I know where the door is, and I know where the bathroom is, and I know where the fridge is, and I know, where the upstairs is and the downstairs are. But if I don't work on that house for a minute, I'm like, okay, I know where the front door is, and man, is this upstairs or downstairs, or I know this fits somewhere, but you know what I mean? And so it is interesting because it's when you walk through it, you've been in that house, for years, and you work with it each day. And so, yeah, like a map that, just a little, what do they call that? Like a visual aid, or, in training, they call it like a work aid, or it's like the little notes that you keep by the side of the computer that tell you, I don't know if you remember old school days, like you would know that somebody was a beginning computer user when they had Control plus C equals copy, right, on a little notepad, next to their computer.
That's right.
So those are the shortcuts. I think that would be great. Yeah. So how to create that, that equivalent little thing that we stick next to the computer. And it's not, it doesn't have to be rudimentary, but it could be helpful, especially when you get into more complex things and when you have to work with others. So for instance, when we're both trying to work in an invisible house with 2 or 3 different people, have different, levels of understanding. Yeah, like a good visual aid would be beneficial. Because we can just call it the thingamajig to ourselves, and you don't have to explain it, you don't have to send it or receive it. but when you're working with others, you know, it's great to have like common, you know, terminology, and not just terminology, but a real visualness of it.
So I don't know the best way, and I've seen some diagrams I really like. I have not yet contributed to any standards around it, and I actually don't know the state of the art right now. And so I would love to know what resources other people have found, but I know these three things are really important, right?
Well, and then we could add datum,
Yeah.
and we
So
could add,
we would want to classify these first, and there are actually a couple of, I think they were up here, just like test diagrams. These are some of the ones we've been testing in the course.
oh yeah, there it is, right there. Okay.
Right. The transaction is the verb. It's the thing that happens, and any transaction has one or more UTXO inputs and one or more outputs. All UTXOs have value in them, and some of them have datum. We know that, for example.
Right, and value in Lovelace Ada.
Right, right. Value is all the tokens in a UTXO, and there always has to be Lovelace in a UTXO. And sometimes the value has other tokens as well, native assets.
Right. Look at it, it's right there. Okay, perfect. Okay, perfect.
So this is an initial attempt at defining a couple things, but I bet it can be improved upon.
No, this is exactly. Yeah, this is exactly what I had in mind. That's hilarious that we've just got it a little bit farther up the chain.
I'll grab a link to this guy. Okay, and so there's some stuff to review there, but I think this is a growth area for this PPBL course, is improving those visuals.
And then making them in that sense of this is on the job as we were working. I guess it's easy to sort of, you know, leave it back behind because it's like, oh yeah, these are really simple concepts for, you know, once it gets sort of firm in the mind. And that's why I'm a little bit like, is this too basic? But there is something magical, I think, maybe when it has to do with when things get super complex, or when something goes wrong, or when there's a group, when it's not just one developer, when there's multiple developers, so that then you know, those workflows of you know, logical gates, like if this contributor token, or if, you know, if this contributor token with an admin token, you know, then, you know, like just the logical flows diagramming. So then you can see mistakes. It's like, oh, we're looping through this, but it's exiting now because of this, and we forgot to check this, or, you know, like those type of things. The visual, I feel, can unlock, you know, it can unlock some efficiency.
Mm-hmm. You're making me think the right metaphors too along the way. The kind of the technically sound visual and the metaphor that's going to hit people right where they are to describe different elements of the thing. One of the things I've seen consistently as kind of the breakthrough moment for people learning Cardano development is the moment when they're able to say, oh, right, the validator doesn't do anything.
Okay.
It takes no action. What can a validator return? A Boolean. True or false.
Of course.
No.
Right.
Right. And that, for me, was one of the hardest things to really understand. And I've watched it over and over again. Like that's the moment. The validator. One of my favorite ways to think about it lately is I can make mnemonics just by opening up a wallet and generating a new mnemonic phrase, and that represents my keys.
Okay.
Okay. And those keys actually mean that I can spend the UTXOs at the address that I just generated.
Okay, I got that. Yep.
Right. That's what my private keys can do. That's the only thing they can do. Right. They can unlock the UTXOs that are at my address. Well, a validator is just a way of creating a custom key. It's a way of building an address like this one right here that doesn't come from a mnemonic phrase or a private key. It comes from custom logic, right? There are no mnemonics associated with this address, is a different way of saying it. Where did this address come from? It was derived from this custom key right here. That instead of just representing a private thing that should be held dear, it represents a public statement of the rules for how to spend from this address. How does that feel?
Yeah, that's one to mark as the bookmark for the on the video, because that is for it does feel like that is a key concept that's not trivial, but is foundational. That these mnemonics create wallets. Wallets are addresses. Validators create wallets that are addresses. The mnemonic private keys are private. These validator are sort of public or publicly useful. Just yeah. I think I feel it. Yeah. You know, the metaphor that resonated for me was the bodega man, you know, saying that you can get ice cream at certain points of the day. That was the metaphor that sunk in for me. It's like, oh yeah, and they don't do anything. They're just a yes or a no. You can or you can't, type of thing.
If I pay the ice cream man the right amount of money, he gives me ice cream. But if I don't input the right amount of money, I'm not going to get my ice cream.
Well, and then the way that we were saying, it's just like, you know what, it's, you know, he can also be like, no, there's a rule in place. It's like no ice cream after 10 o'clock, or Tuesdays, no chicken shawarma on Tuesdays. Sorry. And yeah.
All right. So now let's jump to item number 3. Let's keep this in mind, and this is a quest that we're all on. And someday we will have tried and true visualizations that people who have never thought about this stuff before, they'll look at and they'll be like, oh, okay, reasonable, got it.
Yeah.
Right. But we know we don't have this yet. And so now we can practice by continuing to look at additional examples, looking for patterns, and beginning to generalize what are the crucial parts we want to see. So we've got this assignment. Whoops. And it's described as we just looked at a moment ago. But just to frame this, right? What's the assignment? It's to write a validator, write the custom logic for one of these custom keys we're talking about, and then show that you know how to use it. Okay. Claudio, are you set up to a place where you want to guide us through what you've done so far, and we can start troubleshooting?
Okay, I'll show you. Hi, can you see me?
Hey, yeah, gotcha.
Well, I mean, I don't have a question. I solved the thing. I did it, but I just wanted to discuss a couple of things related to this. The main issue, I think, is that this exercise forces us to become familiar with script context, which is a very huge object, very complicated, and we have to unstructure it and get information out of it. So that's the main challenge, I would say. A couple of things happened. Last week, I think you started with Martin trying to how to get an address to check how much you pay to that address in the transaction, for instance. Okay, so you started exploring the signatories. So maybe I should share my screen and show you the little piece of where I did it. Should I?
Oh yeah, excellent, thank you. And I'm taking some notes on the Miro as well. I think that note about destructuring script context, we could add just a tiny bit more scaffolding there to help people.
Yeah. Okay. So let me just share and see where I'm at. So here's my validator. So I made two versions of this. One according to the logic we were discussing about. So for people to understand the context, in the script context, where you have all the information about the inputs and outputs of the transactions, you also have a field called signatories, which is supposed to have all the signatories of the transaction, right? So this is the validator I did. Let's see if I can make it more visible. So this bit here, in this case, I check in the signatories where I have just one. So this is another detail with the assignment 301 is that it's under-specified. So it doesn't quite tell you everything you had to do. It just puts some constraints. So you had to figure out and make decisions about how to implement that. So one possible solution, which is not the best, I will argue later for a better solution, but one possible solution is to allow the person who signs a transaction to withdraw exactly 7.5 ADA. Okay, so this is the condition. Get signer amount, first signer, 7.5 ADA. And also we had to check that it's only, in this case, it would make sense that it's only one signer at a time making the withdrawal. Now, to my surprise, when this has to do, the other problem is that Cardano CLI is very much low-level tool to build transactions. It's almost like an assembly-like tool. So with the schema we have to build unlocking transactions, if we just build that, the signatories list is empty. It seems to me that it doesn't get populated till you actually sign the transaction, okay? So the first build block we do with the Cardano CLI, let me show you the one I mean to be clear. So this is for locking, and then for unlocking. This will be a transaction for unlocking, right? So we supply all these, redeemer, datum. But if we just submit this transaction, the signatory list is empty. Okay. So I find a workaround. There's a way you can force the information into the transaction, which is called require signatories, require signer file or hash. Let me see where it is. It's something we haven't talked about before, so I thought it was interesting. Let me see what it's. This is this line here. You see, to build the transaction to unlock, I put it up. You had to enforce the required signer hash. Okay, and then I can check that I have a signatory, and I can check how much I pay to the signatory. So that's one thing which I find interesting. The second thing that I found interesting in this context is when you calculate how much you. There are two more questions here in the assignment to me. Who pays the transaction fee for this withdrawal? Because I can do this with just one person, but it's also not specified. I can do several withdrawals in the same transaction to several addresses. So in that case, who would be the fair person to pay for that fee? I decided that should be the contract that pays for the fee. Okay. So the fact of withdrawing money for the recipients is purely passive. So in fact, those recipients shouldn't necessarily have to sign. So I have a different solution to do that later. But in the case I have this, since this is the person paying the, you see, in my case, I paid the fee and the collateral. Sorry, I went off the grid. But this signer is also the one who pays the, I put the fee and the collateral for this signer. Therefore, if I put the change address back to this collateral, something interesting happens. Sorry, if I put the change address back to the person who withdraws, when I build the transaction and I check it, it will tell me it's okay, it's only 7.5 ADA. But when I actually submit it, it generates one additional UTXO with extra ADAs to the account, and then the validation fails. So the validation offline holds, but the validation online fails. So that was the first time I had this kind of tension going on, and we haven't discussed that. So those are the two issues I wanted to discuss with you guys. And totally agree with Newman's starting point. We need, for instance, a really good representation of the script context and how to disclose auxiliary components, because it's a huge object and very hard to navigate. So I'm very surprised that IoT hasn't done that yet, because it's a crucial bit of education that it's kind of missing there, to me, at least. So I don't know what you guys think. I stop sharing now. You decide what you want to do. So those are my questions. I tell you the other thing for the withdrawal amount. I did a different solution, which is to check to allow any amount of addresses to withdraw, and I checked for each of them that they withdraw that. And I did that instead of scanning the signatories, scanning directly the outputs. You can collect the addresses you paid out in the outputs. You had to make a list, and then you had to simplify that list in case of the repetition, because, for instance, in this, the logic, it tells you that the total amount should be 7.5 ADAs, but it doesn't have to be in a single transaction output. So, for instance, here I allowing it to withdraw 3 times 2.5 ADAs, okay? In which case, in the list of outputs, that address will appear 3 times. So when you collect all the addresses, then you had to eliminate duplicates to just have the set of distinct addresses you paid to. And then the logic checks that to each address you paid only 7.5 ADAs. So that's an interesting, I mean, for me, it was interesting. It made me learn all these things about context. And especially that tension in the offline validation and online. But we started seeing with Nick's examples of the time intervals, of offline validates, but when you submit it, it clashes. Here's another example when that happens. So that was for me interesting, because it's the first time we see the tension between offline and online validation and what it could happen. And then I'm hoping that part of the things that building transactions in this way, makes you understand things how it works, but it's very not very helpful. So hopefully we'll see with Mesh and other tools to build simpler ways and more powerful ways to build these transactions, right? So I know that's coming later, so let's not get ahead. So anyway, I don't know, James, tell me what you think about these matters, but what should be?
Oh my gosh, I'm so excited. I'm so glad we have that recorded, because you just laid out several different things that we can touch on over time, and great ideas for like future development of the course. I'm curious what resonated with everybody else here most. Any concepts you want to start with?
Sorry, how do I stop sharing? So maybe you want to show us something on your end, James.
Yeah, where's this? There's a little Zoom guy. I can't see it. Sometimes it's the little horizontal strip should be floating around somewhere on your screen.
I don't see it. Let me see. Sorry. Okay, maybe I just should leave soon and rejoin so you can.
Agustin, how you feeling?
I am fine. You?
Hey, good. Just got to share with everybody that the module was out there, and that you and I have some questions for everybody. when we're ready to talk datum, but that's coming.
Nice to
Good to see you.
hear that. I just wake up, so I just joined late, but
Start the day with a little bit of this. I like it.
good.
So I got Claudio will be right back. But he just shared, here he is. Yeah, let's wait for him. Hey.
There. Thank you.
Gotcha. I'm curious. Yeah, I heard a couple of different entry points for really exciting stuff we could talk about. But what did everybody else hear when from that share out? Anything that was confusing or brand new to you, or anything that was like an aha moment that you want to explore more? Mix, what do you think?
I just wanted to point out a little bit, maybe a security issue. Of course, it is possible in some cases, if you guys want to pay the fee from the UTXO, you are unlocking from the contract. It is possible, there's no problem. It has its own use cases. But since, we always talk about deterministic, you have to be careful about doing that. And you have to be very deterministic about doing that. You should not open a possibility that someone can do it or not, but you have to explicitly tell that the contract should do it or allow it or not. And because of that, we have a function, if we call it a function called txinfo fee. It is inside a script context, which can give you the actual fee that transaction going to cost. And then you can get that number, deduct from the input, and then you can be sure what would be the output. I mean, like 100% sure. So if you want to do that, and if you want to pay the fee from the UTXO, I really highly recommend to use txinfo fee. Otherwise, your transaction will prone to have some vulnerabilities like multi or double satisfaction, or all sort of stuff that, for example, even batching, because some batching are not good actually. But yeah, that was actually a great thought process, Claudio.
Okay, great info, Nick. Can you tell us, when does the txinfo fee get computed? When we build the transaction, or only once we submit it?
No, when we are building the transaction, the one actually you called offline, everything happened in that. So if the offline is successful, then we can be sure online would be successful as well, or as we know, aka submitting stage. But and because of that, we don't normally pay a failed transaction fee, because the fee was computed and calculated and determined at offline before submitting.
At the build step. Yeah,
exactly, at build step. So if your transaction failed at that stage, for example, you cannot pay that fee, or you do not have that fee, or your contract doesn't allow you, something regards to that fee, you cannot pass that build stage. You cannot pass that offline stage. So you won't reach to the online stage and paying a failed transaction, which in, for example, Ethereum, it doesn't happen. You cannot know that your transaction will fail or succeed unless you submit it, unless you put it on the blockchain. And you have to hope that, okay, I hope it will succeed. But in Cardano, not just in Cardano, in any UTXO-based blockchain, namely Bitcoin, Bitcoin Cash, Ergo, and of course Cardano, at building stage, that fee gets calculated. And you can know it by a script context, or by a function called txinfo fee. You can get exact that number. And actually that one actually have some nice use case. You know, maybe in future we can explore it about randomness. If you want some kind of randomness, or like some sort of number which would be kind of random, actually that number can help you to do that, to implement randomness in a very deterministic environment.
That's a cool idea about using the feed to use
Yep.
random.
You can just tingle or temper with the datum or redeemer to just post some different random data, which we can do that. And because of that, the size of transaction or the computation change, therefore the fee number change. So it is, of course, the fee is deterministic, we can know it, but since we have an input that we can decide that, like we can make it random, like a redeemer, actually the end result would be a random fee. But that random fee will be known before submission. So if someone have access to that redeemer, they can know what would that random number be before the submission. So yeah, there are some use cases. We can create some games around it. But yeah, in a deterministic environment, fee is a kind of random number we can get.
It's a good point around context and like, first of all, Claudio, a few things. I'm so excited that you played around with the transaction enough to recognize that, oh, there could be 3 different outputs that add up to 7.5 ADA, for example. And I really encourage everybody to do that. I think one of the best ways to understand how validation works is after you build your own validator let's say after you get an initial unlocking transaction to work, then play with that transaction, right? And this is essentially what testing automates in the long run. And you want automated tests, deterministic tests, you know, for kind of let's call it industrial level, you know, use cases. But while you're learning, simulating for yourself that testing process by saying, what if I build a transaction this way or that way or that way? Do I hit the error I expected? It's a really good thing. I recommend everybody try to do that at least once in validation and make sure you're getting the errors you expect. That's really cool. I really like what you're saying about context and how this helped you dive into it. And it's really cool that you discovered txinfo signatories. Martin, we figured out a way to do this project without signatories last week, right? Not sure if he's fully online.
Yeah, sorry,
Right?
I'm busy on the project on the side.
But like as we looked at last week, you were kind of looking for a way to just see where the funds should be going based on the inputs and outputs, which is a great exercise. And then we see that, oh, actually script context has this other field in it, txinfo signatories. Isn't that interesting? But then it leads to this place of, well, if I use that function, right? Here's an example. If I use that part of script context in Plutus, as Claudio showed us, now I actually have to add a line to my transaction build. I have to add a required signer there. And there's advantages and disadvantages to that, right? That's a very, very good insight. I like connecting it back to what Mix is saying about the fee. Right? By the time I build a transaction, think about what happened. If I'm able to build a transaction successfully, I know that the validation has passed, at least on Cardano CLI, right? That build step is where the validation is checked. And by the time build happens, like Mix is saying, I know what the fee is going to be for this transaction, right? As such, that fee can be read in context. But let's apply that same thinking to signatures. In the validator, I can only say who the required signers are. Right? What are the pub key hashes that are required here? And I can use that in validation. Well, this value has to go to this pub key hash, for example. But what I can't validate is that someone actually signed the transaction. And it's a subtle difference, right? At the build stage, there is no signature. I can only build the thing and I can say who has to sign this, and I can validate against that. But when it comes time to actually signing, that's the next step. And that's where then a transaction that passed validation can fail. Oh, it has the wrong signatures, right? That's kind of subtle, but I think a really interesting thing to think about. Mix, what do you think?
I just came up with some maybe crazy idea. I mean, in regards to fee and actually TX signatory and signing the transaction. You know, guys, we always have to be careful who is going to sign the transaction regards to the smart contract, because that means someone is going to unlock that UTXO and obtain that UTXO. When all that UTXO has a value, token, made up, data, whatever. So we have to always put a pub key hash somewhere so we can check against that. Therefore, we can be sure the right person signed that transaction. But what if we can use this fee for that? What if we know that, what if we have this condition? That transaction will be successful only and only the fee will be this number. Who knows this number? The only person who built that transaction before that UTXO. So then that fee, the number, is actually kind of a password. And you don't need to put a pub key hash. If you know that number, you can provide the data or something as an input to that transaction by the redeemer, and then the transaction fee will reach to that number, and then you can spend that UTXO. So the contract just check for transaction fee, which is an integer, and if it doesn't reach to that, whether, let's imagine it is 1.5 ADA, or like, for example, 1,535,256. So if somehow someone's try to make this transaction and reach to 55, they cannot unlock it. And if they reach to 57, they cannot. They have to have this number. And you might say, okay, how can I put this number? You can hard code this number into a UTXO, into that UTXO, but that number exposes itself with an integer. What if it is a hash? A hash of an integer, and the contract just check that.
Mix, wouldn't it be smarter to just use datum hash instead?
Well,
Then you also
datum
can just
hash,
unlock if you have datum, if you have the correct datum.
yeah, datum hash, yeah, of course it is possible, but you have to provide that datum hash. But maybe you want to hard code this inside your contract. Maybe you don't want that on the datum. Maybe there are something else inside the datum. Like if you cannot use datum as your input for this transaction.
I like the idea, but I don't see a real use case for it. I don't see why I should do that instead of just providing the bouquet hash in the parameters.
What if I have no accessibility to a wallet, and I want which I want to put that pubkey hash inside the contract. But if I want to open this UTXO 5 years later, and I don't know what wallet would I use by that time, maybe I lost my accessibility to many wallets already.
Hopefully you don't forget how big the fee
Yeah,
should be.
but if I just know a number, just I remember an integer, maybe it is a birthday of someone, but actually it is a fee. And if I remember that 5 years later, I can just come back, create a transaction which reach to that fee number, to that exact number, like, you've seen these people cracking safe and they put their ears into, just moving around that, I don't know what they call that, that's like that circular stuff, which makes a noise. And once it reach to that step, like you will hear a crack noise, it's open. That exactly happened with the fee.
Couldn't I just brute force your fee amount?
It is
Because
possible.
I don't
Yeah,
have to
yeah.
pay any fees because
It is possible if they know it.
if
If
you
they know.
got the number 0.
No, if they know that
75,
I
what-
put this number,
Well,
they
okay,
see
okay.
the
Yeah.
hash.
This is an exercise though, right? It's a thought experiment that would be fun to implement,
Yeah.
to just play with it. That could be a really fun one.
But of course, it can be brute force because you don't need to pay anything. Everything is offline. You can start from the lowest possible fee to highest, which right now is 2 ADA. So
Actually,
kind of,
that's actually not a big set to
Yeah.
sift through, really. That's kind of interesting, right?
But
That
it is.
wouldn't be that one.
But of course, if you tell your secret, people have less effort to just figure it out.
Right.
But I was just, it was just something came up in mind. What if we can use the fee itself as a means to unlock a transaction instead of a pubkey hash?
Future explorations, yeah. Let's bring that one to some playtime if there's a demo of that. I also want to call out Claudio's comments about who pays the fee, because this is a practical question that every dApp developer has to address, right? And so if you're ever going to build anything that's being put in the hands of anyone else, yeah, at some point you're going to make that decision. Who is paying the fee? And that's, I don't think there's any one right answer to that. And it might even be something that you want to be able to talk about with a multidisciplinary team. You might have, the non-technical stakeholders on your team involved in that conversation. Has anyone else confronted that problem in the wild and have ways that you like to think about it?
Sorry, it was an open question, James, or just to Claudio?
Yeah, it's open question. Are there best practices for deciding who pays the fee in a validation transaction?
For me, it's kind of ethical question.
Yes.
And to me, I mean, maybe it is about justice, fairness. And ethically, I think if someone gets a benefit from that transaction, ethically, they can pay the fee. But if they don't get a benefit, or kind of they don't have incentives from the output of that transaction, why they should pay that fee? I mean, the output doesn't necessarily mean always a value. Maybe it's just updating a state of a transaction or something. But I don't know. I mean, I just try to see this in by that lens. Like it's like, I don't know, moral, ethical, but if someone paid a fee, they should get something in return to justify paying that fee. But what do you think, guys? Is it enough to just create a logic based on that or not?
Is it if they get anything, they should pay the fee, or is there like a certain threshold you'd want to define? Like if they get at least this much value, they pay the fee.
Of course, but for example, in case in Equival, I was designing to extend the time of a trade between two parties. Each of them can extend that time, but who should do that? Who should extend that time? And extending that time means just updating a datum. So that's all. I was thinking, who will get benefits from extending a time? That person, that reason, I cannot think of that kind of on-chain, because the reasoning behind that would happen off-chain. So I will open a possibility for these two parties to think about it, and one of them should do it. And by their thought process, they will reach to this conclusion. I'm getting something, I'm paying something. How much this, like, is there any equality or something or not? I'm just paying for no reason. So these anything, actually sometimes it's not possible to determine by us. It's just an option. For example, extending something, extending a time. Maybe it's because, you know, for some people, time doesn't have that much value for other people. Like maybe, you know, it's like, I think you guys heard that, like 1 minute for a person who is near to death is different than 1 minute for, you know, a normal person. So, for example, regards to extending the time, and they have to pay a fee, maybe that extension means and have greater value for a person, therefore they can pay it. But in normal case, no, it doesn't. So they should not do it. And same thing for dead man switch, guys. Maybe in your dApps, you want to implement a dead man switch as well. And for example, you are crafting a contract. Someone create a UTXO and send that to your contract. And you have nothing regards to evaluating or unlocking this UTXO in your contract, because this UTXO wasn't built according to the rule of your contract. So that UTXO will be there for a while. And let's imagine it is just, how much? Just 10 ADA. Right now, 10 ADA doesn't mean that much. It doesn't worth that much, for example. But what if 10 years now, like 10 years from now, and 10 ADA now worth $1,000? Now it's worth something that maybe someone can open or unlock that UTXO. So in my case, sometimes time actually, like the period of time or value of time into people's mind and inside their minds changes this thing, and I cannot determine how they think about this thing. So it's like I'm giving you the option, but besides that, I don't know. Like I was hearing from Charles Hoskinson that after moving forward with this governance, one of the things that would be like high priority to change would be the fee, actually. because in order to change the protocol parameter, they should give like there is this Genesis key, and they should have a clear governance regards to Genesis key. And one of the reason is they want to update this protocol and fees. So I don't know, maybe in future this anything means different. Like right now, I have to pay 1 point something ADA for doing, I don't know, something. So never mind. Like for example, you lock your NFT in JPEG store for selling. How much your NFT worth? 6 ADA in total, like 6 ADA. And then you are thinking that, oh, I just want to take it back, and see, just locking and unlocking just
Right.
costs you around 5 ADA, for example. And you wanted to sell that NFT for 6 ADA. So
Right.
this doesn't look good, like, and you know, so I honestly don't know. But yeah, but maybe good solution would be we will tell to people before doing this action.
Mhm.
Kind of.
You know, another outcome of fees conversation is that it can help us decide what should be on chain in the first place.
Exactly.
If
Yep.
nobody is willing to pay the fee for a transaction, then that transaction is probably not worth keeping on blockchain. Just put it in a spreadsheet.
There is a reason we don't call UTXO in Plutus contract UTXO. We call it value.
Mhm.
Have you guys noticed that? We don't call it UTXO. We don't have something like UTXO in Plutus. We have value. So if something doesn't have that much of value, well, don't put it there.
Yesterday, we looked at the process of making a commitment and unlocking it and receiving some tokens for a treasury. And none of these things really matter too much to us right now because we're using it all on pre-prod with test data, right? And so the current design of this course is, okay, it's a pre-course, but imagine it was on mainnet and you as a contributor or a student had to pay a transaction fee every time you made a commitment to a module. Would it feel worth it to do that? And at the other end of it, when it's distributed back out, you get some reward. And right now it's 2 test ADA and a couple of test gimbals, right? But let's say that the reward for finishing a module was 2 ADA, and the fee for committing in the first place was 1 ADA. And at the time of distribution, it's on the administrators of the course to pay that fee for distribution, so you don't have to worry about that maybe. But is it worth it as a student to pay the fee at that point of commitment, knowing that you'll get a little bit back, right? These more tokens. And is there a threshold there? Is it only worth it if the reward is at least this much ADA or at least this much gimbals or other tokens? Those are all interesting variables that we haven't needed to talk about because we're not putting this thing on mainnet yet. But it'd be a cool experiment to kind of figure out what we would want those numbers to be if it was on mainnet.
And we should also consider how much is too much for people. Like, let's say, yeah, they are going to pay 5 or let's say 10 ADA in total for fee. Okay, 10 ADA right now, it's like $2.5 if by this price. $2.5 means different in different places. $2.5 for some people is I can have 3 full meals a day. For some people, it actually doesn't mean anything. So yeah, there are so many like ethical, moral, technical questions in regards to fee, which I personally like. it is really related to the context.
What a session. We started with, talking about a particular course assignment. We thought about visualizing these things. We know we have some drafts and there's some work to do still there. We thought about another assignment and some of potentially the supporting resources that could be built there. And a lot of people have already started pushing changes to some of the modules. Similar thing, question ahead for all of us is, how might we want to add supporting materials to a project like 301? Do we leave it wide open and hope that everybody gets out of it what Claudio did? Or do we understand that not everybody's going to go that deep? And how can we give them scaffolding to get there? Maybe this question is still in the back of people's minds. It's certainly in the back of mine. But then we made it all the way from these technical concepts into some ethical conversations. Well-rounded session, y'all. Thank you.
Yep. Thank you, guys. Thank you, James. And
That's-
maybe I should add some disadvantages for fee as well.
Save that. I actually do have to jump, unfortunately, right now. But yeah, like let's keep fees on the agenda as a potential spot. Okay.
Sure.
I think that would be a good deep dive, and it sounds like a series of deep dives just looking at script context could be really interesting.
I think that comes to my mind with this discussion is bubble fees, a feature that is planned to be implemented in the future in Cardano. And that's pretty interesting. Maybe we can discuss it in our next session.
Absolutely. Yeah. I mean, so think about Babel fees, Midnight, the ongoing rollout of Hydra, Mithril, the list goes on, right? Hopefully what we are cultivating right here can create a space that as each of these new features comes online, we're ready to learn about those things together. I would love for a regular structure here to be that we are experienced Pioneers is open for enrollment right now. I'm not sure when it's going to start, but it'll be really cool to look at that stuff together, and then to think about, hey, how might we need to add that to the course? So yeah, it's very exciting to see these deeper questions start to be emerging, and I'm excited that we get to keep looking at them together.
It's nice.
All right. Hey, keep ideas coming. The other question that remains open is, how should we spend our time together? And anybody, if you have creative ideas for different ways to structure this session, we know we've got this one right here, and it worked today. We know that yesterday we ignored that structure and just jumped in to looking around at stuff, right? And last week, for the last 3 Thursdays, we've had special sessions about module 302, and that can happen again. But I don't think we've seen all the options there. And so if anybody here, if you wake up with a breakthrough idea, hey, what if we did a live coding session this way? Please be sure to bring that. Let's keep experimenting. Cool. All right.
Perfect. Thank you so much.
Thank you all for your time today, and see you later or soon or sometime.
Bye.
Cheers.